day, everyone. This is the presentation of Group 6. Today, we're very excited to introduce and guide you through the intriguing realm of cluster sampling. So, what is cluster sampling? Cluster sampling is a probability sampling technique where researchers divide a population into multiple groups for research. So, researchers then select random groups with a simple random or systematic random sampling technique for data collection and unit of analysis. Cluster sampling is defined as a sampling method where the researchers creates multiple clusters of people from a population where they are indicative of homogeneous characteristics and have an equal chance of being a part of the sample. In this sampling technique, researchers analyze a sample that consists of multiple sample parameters, such as demographics, habits, backgrounds, or any other population attribute, which may be focused on conducted research. This method is usually conducted when groups that are similar yet internally diverse from a statistical population. Instead of selecting the entire population, cluster sampling allows the researchers to collect data by bifurcating the data into small, more productive groups.
So now, let's proceed to steps to conduct cluster sampling. First, sample. Decide the target audience and also the sample size. Second, create and evaluate sampling frames. Create a sampling frames by using either an existing framework or creating a new one for the target audience. Evaluate frameworks based on coverage and clustering, make adjustment accordingly. These groups will be varied considering the population, which can be exclusive and comprehensive. Members of a sample are selected individually. Third, determine groups. Determine the number of groups by including the same average member in group. So make sure each of these groups is distinct from one another. Fourth, select clusters. Choose clusters by applying a random selection. And last, create subtypes. It is bifurcated into two-stage and multi-stage subtypes based on numbers of steps followed by researchers to form clusters.
And now let's proceed to cluster sampling advantage. These include first, consume less time and cost. Sampling of geographic segmentation divided groups require less work, time, and cost. It's a highly economical method to observe cluster instead of randomly doing them throughout a particular region by allocating a limited number of resources to those selected cluster. Second, convenient access. Researchers can choose large sample with this convenient sampling technique and that will increase accessibility to various clusters. And lastly, data accuracy. Since there can be large samples in each cluster, loss of data accuracy in information per individual can be compensated.
And now let's proceed to disadvantage of cluster sampling. These include possibility of underestimation, sample size chosen potentially due to time or cost constraints, might be too small to accurately represent the population under study, leading to the non-representative data or results. Limited scope. Cluster sampling is generally limited to a certain area or population and is challenging and expensive to use in nationwide or global studies. Bias. If the, if the cluster used are not randomly selected, the study's results may be biased and unreliable. In comparison to simple random sampling, this technique can be useful in deciding the characteristic of a group, such as population and researchers can be implemented without having a sampling frame for all elements of the entire population.
How to get a cluster sample. The process of collecting cluster samples requires a few simple steps. Step 1. Define your populations. Begin by defining your population and determining its size. This will help you identify the number of clusters needed and decide on appropriate sample size. Step 2. Divide your sample into clusters. Once you've determined your population's size and the number of clusters needed, it's time to divide your sample into smaller groups. This can be done by geography, demographics, or other criteria that suit your research. Step 3. Randomly select clusters to use as your sample. Next, select your clusters randomly and use them to form your sample. Make sure you choose enough clusters to represent your populations accurately and cover all relevant factors. Step 4. Collect data from the sample. Finally, collect data from the sample using surveys, interviews, or any other data collections method that suits the study. This helps researchers gather accurate information representative of the populations at large.
Of cluster sampling. First, one-stage sampling. One-stage sampling, also known as single-stage cluster sampling, is a method where every element with a selected cluster will become a part of a simple group. This is often not feasible in the target population if the bus and cluster are too large to include fully. Two-stage sample. Two-stage sample is more feasible and realistic method of sampling in case where the population is too large or scattered over a large geographical area. In this method, simple random sampling, sometimes another method like systematic sampling are also used, is to select elements from the selected clusters, further narrowing down the desired sampling size. Third, multi-stage sampling. Multiple stage sampling takes two-stage sampling further by adding a step or a few more steps to obtain the desired sampling group. This means that you need to use multiple steps to obtain the desired sample, and at each stage, you are left with a smaller and smaller sampling group. This is the most complex of a three-cluster sampling method, but it is also most advantageous for a very large population and geographical dispersed population.
Applications of cluster sampling. Cluster sampling can be used in a variety of research contexts, including surveys. Help researchers gather information from a large population efficiently and cost-effectively. Marketing. Use marketing research to identify customer trends, preferences, and buying habits.